Alright, so in this activity what we're going to learn to do is how to calibrate the light reading from a microbit into a lux value. Why that matters is plants care much more about light intensity, because if the light isn't too intense, the plant isn't going to have enough energy to undertake photosynthesis. So you're going to need one other piece of equipment to be able to do this. You're either going to need to download a light meter app for your phone, and usually the light meter or the light sensor on your phone is somewhere on the front part of the screen. Usually it's associated with the camera. Or you're going to need a LUX meter. The apps that you can download from the app stores are surprisingly good in terms of correlations to a LUX meter. So I've got a relatively inexpensive one here of about $20 for a light meter, and I've downloaded a light meter app from the Android App Store. They exist on iPhones as well. And they're the same distance from the light source. And notice the readings are well within any kind of error bar associated with this level of equipment. Now what you're going to do is we need to collect some data to help us with the calibration. Okay? So one of the hardest things to do with this is to make sure that you're getting roughly the same amount of light flux hitting both of your sensors. So this one, where it might be useful to either have a light source that you can start high and lower, and so you know that you're maintaining the distance, it's best to use a light bulb or some kind of broader source, not an LED light source, because those tend to be a little bit more directional than an incandescent type of light source. And when you slowly raise or get your light sensors closer to the light source, as my light source is over my head, is notice my light values are going to change, and we're going to correlate that to the reading that we get on our microbit. Okay? So one of the first things that we're going to need to do on our microbit setup is we're going to need to collect some light data, or just have it read some light data. So I'm going to make a variable. I'm going to call my variable light from bit. Okay. I am going to set that light from bit in my forever loop, and in my input block I am going to grab my light level. And so now I've got set light from bit to light level, so now it's going to read it, and I want to show that number on my screen. So in my basic block I get the show number, and then I'm just going to throw that variable data in there, and I'm going to slow this down just a bit so that I can actually read the light reading on my microbit by 2 seconds. Okay. So you'll download this to your microbit, and it's going to start giving you light readings. Okay. Then what you're going to need to do is to take your microbit, and whichever device that you're using, get the reading that it's going to show you on the screen, correlate that to the reading that it is showing you on your phone or your LUX meter. And I've already done that. It's not that exciting of a task to do. Okay. And so I have made a data table here in Microsoft Excel where I started low and I went high. Okay, so I just gradually turned my light up. I just had a little knob, so I slowly turned up my light intensity so I maintained the right distance once I got my reading set. There's lots of ways to do it. And so now I've found that it takes about 10 to 15 data points to be able to get a decent line graph or exponential graph. Kind of depends on how your bit's reacting. And now what we have to do is figure out what kind of light curve we're going to need for this. So in Excel, you can go Insert, and you're going to make a scatter plot. Okay. So now I've got my little data points. Right? It looks very linear in nature. And as you increase the intensity, what starts to happen, you'll see, is that this curve or this line will start to flatten out. Because you saturate the microbit light. So when you take it out into the sunlight, it's going to saturate, and it's going to get you a typical reading of about 13,000. Right? It'll stop at 1,023 because that's what it's converting the numbers to, from 0 to 1,023, and you're just stuck. But within this range, you're in very good shape. Okay. Now plants tend to want to have value somewhere around 5 to 12,000 lux. You know, it kind of depends on what type of plant that it is. So this is actually a pretty reasonable assumption that we can make here. So what we're going to do is right click on your little dots in your chart. You're going to add a trend line. And in Excel, it'll give you options of what might be the best fit, right? And so now we can go through and we can kind of go, oh, that one might be okay. Linear looks like it's mostly the best one, and it's usually the case. Right? The logarithmic curve, maybe. So let's go with linear. All right? And you're going to click Display Equation on Chart. And now you're going to get your equation. And my equation here tells me y, so that's the y-axis, which is the LUX reading, because that's what's over here on my y, is equal to, it's the classic y equals mx plus b linear equation, is 11.5 is my m, minus the b, which is where it's going to intersect with my y-axis, is actually minus 30.3. So now we've got an equation that we can use. So let's go back to make code. I'm going to take these two blocks out of my code just for a second, because one of the things that I want to do is change this set statement here. And I'm going to end up using some math here because we have an equation. So I'm going to go to my math block. I'm going to choose this 0 times 0. I'm going to pop it in. So I'm going to set my light from my bit variable. I'm going to have that be my light reading. Oops. And I am going to change that to 11.5. Okay. Now we need to worry about the b, or the intercept. So I'm going to go back to my variables, and there's this change block. So now I'm going to change my light bit by a minus 30. Okay. So this is basically an equation. You can do this all in one block if you wanted to. I just find it a little easier to do it in two. So now my light bit, my light from bit is going to be minus 30. Now, sometimes to get kids thinking about LUX values, I'm going to actually make a new value, and I'm going to call it LUX, because it's a useful unit for the students to know. So what I'm going to do is I'm just going to do a redefinition here. I'm going to set LUX to my variable light bit. Okay. So now I know that anytime I use the word LUX as anywhere in my program, that's going to mean that it's already got the equation converted from the core or raw reading on the microbit to my LUX value through this equation. Okay. So now I'm going to drag back in my show and number. So instead of from light bit, I'm going to show LUX. Right? And so the nice thing here is that, again, I'm showing my LUX value, and now I am going to do a pause for 2,000 seconds or 2,000 milliseconds, just so I can have some time to write down or record the data. Right? That's not necessary if you just wanted to keep scrolling across the screen. But that's really all that we have to do to be able to calibrate our variable, to be able to make sure that we're collecting data from the bit, converting it into a LUX value.